Welcome from Maths and Science by IITN channel. Maths and Science by IITN channel. For the benefit of Maths Olympiad and JEE aspirants, I have been publishing lectures on mathematics. Until now, 20 lectures have been released, including shorts, from this channel. Now, as a part of our progression towards number theory, I have explained some examples on number theory, algebra and geometry also. Today, another good example on number theory I have taken up. That is, how to find out whether a number is a prime number or not. Whether prime number or not. It will be very difficult until and unless we follow a particular procedure to find out whether a number is a prime number or not. I will explain that in detail. And if you feel there is a value addition to your knowledge because of my lectures, please subscribe to my channel for regular updates. And I will give the link to the previous lectures in the description of this video. My channel name is Maths and Science by IITN. It's written at the bottom, Maths and Science by IITN. Now, let's delve into the problem. 5231, it's a 4-digit number. Whether it is a prime or not, we have to see. What is a prime number? Prime number should not have any factor other than 1 and the number itself. That is a prime number. And we have to see 5231 whether it has got any other factors other than 1 and 5231. First step. We have to check whether it is divisible by 2. First is divisible by 2. A number can be divisible by 2 only if it is an even number or ends with 0. Even number. That means here 5231 is an odd number. Hence, not divisible by 2. It doesn't have 2 as the factor. Second step. To check divisible by 3 or not. A number will be divisible by 3 if the sum of the digits is divisible by 3. Please remember this. Sum of the digits, that is equal to 5 plus 2 plus 3 plus 1. That is equal to 11. Not divisible by 3. Implies number is not divisible by 3. That means 3 is not the factor for this number 5231. Here our number is 5231. For even number it should be divisible by 2. Divisible by 2 means it should be an even number. Divisible by 3 means the sum of the digits should be divisible by 3. It's not divisible by 3. Next, whether it is divisible by 5. For something to be divisible by 5, the last digit either should be 5 or 0. Last digit should be 5 or 0. But here last digit is equal to 1. Implies not divisible by 5. That means you go by step, don't leave any step. It is not divisible by 3. 2, 3 and 5 are not factors of first conclusion. 5, 2, 3, 1. Now we have to check whether it is divisible by other numbers or not. Here it is very important step. Find out square root of n. Here square root of 5231 is equal to approximately 72.3. Find out the square root. What is the 4900 square root is 70. 70 square is equal to 4900. 71 square is equal to how much? 71 into 71. Please see. (5041) and 5231. 72 square is equal to 5184. Then 5231 is approximately 72 point some decimal. That will take it approximately as 72.3. You can cross check also. That means we have to take a prime number below square root of n for the, what is the step? Take prime numbers below square root of n to find whether the given number is divisible by those prime numbers less than or equal to square root of n. Here, initially what we have done in the first step, we have found whether it is a even number or an odd number, to find whether it is divisible by 2 or not. Then we found whether the sum of the digits is divisible by 3 or not, to find whether it is divisible by 3 or not. Next step, we checked whether the number is containing last digit is either 0 or 5, to find whether it is divisible by 5 or not. We found it is not divisible by 2, 3 and 5. For higher numbers, we need not go beyond 5230 numbers. It will be sufficient if you go up to square root of n. What is the n given here? Here n is equal to 5231. What is square root of n? That is equal to 72.3 approximately. That implies if we find any factor as a prime below square root of n, then it is not prime. If we could not find any number, any prime number below or equal to square root of n, as a factor, then it is prime. Please remember these two sentences. Find the square root of n and then take the all prime numbers below square root of n and check whether any factor is there in those prime numbers, whether this particular number is divisible by them or not. A number, for example, 7 may be a prime by itself, but 56 is divisible by 7. Hence 56 is not a prime. In this case, 5231 up to 72, if you take the prime numbers, some prime numbers by themselves they are prime numbers, but there may be a factor for 5231. We don't know. If you find any factor below square root of n, any prime number as a factor for this given number, then that given number is not a prime number. If there is no number as a factor below square root of n, below or equal to square root of n, then that particular number is a prime number. This is a very, very important step. Please try to understand this step in this example. Step by step we will go. What is square root of n? Square root of 5231. That is equal to approximately 72.3. That means any prime number less than or equal to 72 to be considered and to be checked whether that is a factor for this number or not. What are the numbers, prime numbers less than or equal to 72? We have already checked 235. We need not cross check again. Next prime number will be 7, next will be 11, next will be 13, next will be 17, next will be 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67 and 71. How many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That means we have to cross check now only with the 17 numbers. Whereas 5231 is a very big number. It's a very big number. 5231 is a very big number. But we can cross check only with the 17 numbers. Then we can decide whether it is a prime or not. That means even if you take half of the numbers of 5231, 2616 numbers are there for which we have to find whether particular number is a factor or not. If you take 1/3, it will be around 1800 or 1700 for that matter, 1743 something like that. 5231 by 5, because 5 also we have checked, that means 1046. That means almost we have checked up only up to factor 5. That means there are 1046 numbers left over between this factor and the 5231. Instead of checking the 1046 numbers, we are checking only with 17 numbers and finalizing whether the particular number is prime or not. Please try to understand. Instead of checking here, if you see, instead of checking the 1046 numbers with 1046 numbers, we are checking with only 70 numbers with this trick. With only 17 numbers and finalizing whether it is a prime or not. It's a major very good trick which you should know it and apply it in your examinations. Now, what are the numbers? 7, 11, 13, 23, all these numbers are there. These are very simple arithmetical calculations, a division. You have to see whether a remainder is there or not for the given number. And for 5231, please see whether these numbers, let us see. For example, 7. I will do only 1 or 2 steps. Afterwards, other steps as a homework, you do it. 5231 divided by 7. What it will be? 7 7 ja 49. 7 4 ja 28. Again 7 7 ja 49. Point something. That means it is not divisible by, an integer is not coming, some decimal is coming. That means not divisible by 7. Let us take something like 17. Let me take, in between you do 5231 divided by 17 is equal to 17 3s are 51, then 1 3, that is not divisible, hence 0, 1 3 1. 17 7 ja is how much? 119. 12 is remaining. Again 7 something. That means it is also not divisible, some decimal is coming, integer is not coming, not divisible by 17. Shall we try with 43? In between numbers you please cross check. All the numbers you have to cross check. I am only doing, for example, 43 1 ja 43, then 9, 93 will be there, 43 2 ja 83, 86, so that 7 will be remaining, 71, that is 43 1 ja 43, 71 minus 43 is 28, 28 divided by 43 is a decimal. Let's not worry about the decimal, what is the number in the decimal. If it is a decimal, not divisible by 43. If you see, this number will not be divisible even by 71. 71 is the number which is a prime number below 72. Seventy-one seven ja 497, 24, 241. 241 means 71 3s are 213, and afterwards it is a decimal. That means it is not divisible. It is not divisible by 71. The whole. In between gaps, you please complete the table. And it is not divisible by 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 43, 41, 43, 47, 53, 59, 61, 67 and 71. Not divisible. Remainder present. Remainder is available after division. Not divisible by any of these. All of these. Hence our conclusion is 5 to 31 is a prime number. Like this, we have to find out prime number, whatever the number given. You can take small numbers also for practice. Let us say, one number let me take for another example. 137. Is it prime or not? First step, not an even number implies not divisible by 2. Second step, sum of digits is equal to 1 plus 3 plus 7, that is equal to 11, implies not divisible by 3. Third, last digit is equal to 7, implies not divisible by 5. Then, what is the fourth step? Find square root of n, that is equal to square root of 137. What is approximately square root of 137? Approximately square root of 137 is 11.7. 12 square is 144. 11 square is 121. In between 12 square and 11 square it is there. That is 11.7. Therefore, less than or equal to square root of n, number is equal to 11. Maximum number. That means we have to know the primes up to sixth step. Primes up to 11. They are, what are the primes up to 11? Just now we have noted down 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. We have already found out 2, 3, 5. It is not divisible. We have to find out only two numbers for 7 and 11. Let us find out here. 137 by 7 is equal to 19 point some decimal. That implies not divisible by 7. Now 137 by 11 is equal to 12 point some decimal, not divisible by 11. These two implies and previous ones imply not divisible by 2, 3, 5, 7 and 11. That implies 137 is a prime. This is a trick you can apply in your examination and find whether any number is a prime number or not a prime number. Once it is a prime number, then we can apply our congruence and other theorems, and we can find out and apply the theorems like Wilson theorem, Homer theorem. All these theorems I have explained in my previous classes. Around 20 lectures are released from this channel. Maths and Science by IITN. I have spoken about number theory, algebra and geometry. You can refer to those videos, and I will give in the description the link for all the videos, playlist link. Playlist is Algebra by IITN. Algebra by IITN. Another thing can be Geometry by IITN. These two are the playlists. You can use them, see those videos and subscribe to my channel. If you feel there is a value addition to you from my videos, subscribe to my channel and make your friends also to view them and get the knowledge from these channels. And best of luck to everybody. Thank you for listening to me. Thank you for viewing my video. Thank you.